So now we're going to look at the distributive law, and that is a way to use patterns to find the multiplication without having to build the rectangles with the tiles. The process of multiplying polynomials really means remove brackets and is called expanding. So when we were doing the algebra tiles, you may have noticed something about the answers, and looking at the dimensions you might have been able to start to predict what the answers would be, and we're going to formally learn this pattern, which is called distributive law. Distributive law says whatever is in front of the bracket needs to be distributed to, multiplied with each thing inside the bracket. So A times B is AB, A times C is AC. The A is distributed to each thing inside the bracket. So let's look at some examples where we're to expand and simplify. 2 times x plus 3. So distributive law says I have to multiply the 2 by the x to get 2x. But then I have to multiply the 2 and the 3 to get 6. So the answer is 2x plus 6. 2 times 5, take away 3x. I multiply the 2 with the 5 first to get 10. Then I take the 2 and distribute it to the negative 3x to get negative 6x. Now we're going to look at negative 2 times 3, take away 4x. So I'm going to multiply the negative 2 and the 3, and as I'm multiplying with the negatives, let's keep in mind our rule for signs. Same signs positive, different signs negative. So negative 2 times positive 3 is negative 6. Negative 2 times negative 4x, same signs, it's going to be positive 8x. 5 times 3x minus 2x squared plus 1. So distributive law is just not for two things inside the bracket. It can be for a trinomial, 3 things inside the bracket, 4, 5, 6, however many things inside the bracket. You just take the number in front and one at a time distribute it through the terms. So 5 and 3x gives us 15x. 5 and negative 2x squared gives us negative 10x squared. 5 and 1 gives us positive 5. So the answer is 15x minus 10x squared plus 5. So when you have x plus 3 by itself, it's really the same as 1 times x plus 3, because 1 times anything remains the same. So when you have a bracket with no quantity in front of it, we understand that that quantity can be 1. So 1 times some random number always equals the same random number. So 1 times x is x and 1 times 3 is 3, exactly what we started out with. If I have a negative 1 in front, I'm going to distribute the negative 1 in to get negative x and negative 3. So now some say that distribution in algebra is similar to doing laundry. Well, why is that? So your family of 4 has just returned from an exhilarating but muddy fall hike through the local forest. Dad says it's your turn to do the laundry. He reminds you to distribute the load evenly so that the washing machine doesn't break. Mom reminds you to fold all the clothes when you're done and put them in piles for each person in the family. So distributing a load of laundry equally means taking one big pile of dirty clothes and expanding it into more or smaller loads based upon their color and weight of each pile. Each pile then has a weight and color component to it. When the loads are finished, you fold and organize the clothes for each person. So, to do this example, we have to open the brackets. Last time we opened the brackets, there were no numbers in front, it was just signs. Now we're having numbers in front of the brackets as well. So we're going to distribute this into smaller loads if we look at it with our laundry analogy. Negative 1 times x is negative x. Negative 1 times negative 2, same signs, positive 2. 2 times 1, positive 2. 2 times negative 3x, negative 6x. We're going to collect like terms. we're sorting it into the piles for the family. So the negative x and the negative 6x belong together. The positive 2 and the positive 2 belong together in the same pile. Now I'm going to add or subtract the like terms. Negative 1x, take away another 6x, gives us negative 7x. Positive 2 plus 2 gives us positive 4. So now let's look at 4x times 3x minus 5 and negative 2 times x squared plus 1. And this is where it was important that we did the quick review of exponent laws, because we're going to have to start thinking about multiplying letters by letters. Open the brackets. 4x times 3x. 4 times 3 is 12. X times x is x squared, because whenever an exponent is missing, it's 1. 1 plus 1 is 2, because when we multiply variables, we keep it the same and add the exponents. 4x times negative 5, negative 20x. 4 times negative 5 is negative 20, and I have the x. Negative 2 times x squared is negative 2x squared, and negative 2 times 1 is negative 2. Now we're going to collect like terms or do our sorting into piles. 12x squared, take away 2x squared. Negative 20x, subtract 2. We're going to add or subtract the like terms. Well, in this case, we only have one set of like terms, the x squareds. 12x squareds, take away 2x squareds, leaves me with 10x squareds. Simply 12 take away 2. Nothing to go along with the negative 20x, so it stays negative 20x. Nothing to go along with the negative 2, so again it stays a negative 2. So the answer to this simplification, meaning multiply using distributive law and then collecting like terms, gives us 10x squared minus 20x minus 2.